Okay, and the final part of this booklet is all about brackets and order of operations, so BIDMAS. You probably would have called it at GCSE. Now, this at A level causes lots of problems if you're not 100% confident with BIDMAS and brackets, etc. Now, the big problem is your calculators. So calculators recently become really sophisticated so that on the screen, it's written how you would write it by hand. Whereas about 15, 20 years ago, maybe even 10 years ago, calculators couldn't do that. So calculators had to write everything horizontally. So there was no like fractions, there was no surds, everything had to be horizontally. So I just put a few examples in this table just to show you how we used to write stuff. So obviously AB, you would type in A times B. Lots of B plus C, you'd have to type in the times. You have to really emphasize the calculator to mean times. Over B, you have to type that in as A divided by B. A plus C or B add D. Well, this was what will trick lots of people. If you didn't put brackets, then it wouldn't do what you wanted to do. If there's no brackets there, it would use BIDMAS, so it would do C divided by B, then add A, then add D. Whereas if you want A add C first, B add D first, and then divide the answers, you need brackets. So fractions, in fact, have invisible brackets that you don't see. Root A, old calculators would just have a root symbol, then you have to type a number afterwards. Whereas calculators these days, as soon as you press a square root, they'll automatically put a square for you to fill in what you want underneath. So something like root A plus B, you could clearly see that in your calculator. The square root symbol goes over both of them. Whereas on the old ones, they would only use the symbol, then you'd have to put A plus B in brackets to tell the calculator you wanted to work out A plus B and then square root that answer. If you didn't have the brackets, it would just do root A first and then add B. A to the power of B, there's a little hat symbol, which I think lots of you have seen during working at home. And A to the power of B plus C, again, you need brackets from the B plus C. Otherwise, if there's no brackets, it would do A to the power of B and then add C for your answer, as you want to add C to the power. So the main thing I'm trying to say here is anything like surds or fractions or powers have invisible brackets. Yeah, so that actually helps with stuff like chain rule, because then you can spot the brackets, you can spot what your U would be. And it also helps just a bit when you type in your calculator and just appreciating that brackets are important. So all we're going to do is we're going to have a go at looking at the written convention and try and write it using a horizontal version. So how would we type these in a calculator 15, 20 years ago? So if you want to have a go at some of them yourself, press pause. If you want to work through a few with me, then press pause. It's up to you. So 2 lots of y add 3. We'd have to type that in as 2 times y add 3. 2 over x, we just do 2 divided by x. 2 plus y over x. Well, if I did this, 2 plus y divided by x, my calculator would do y divided by x first, because BIDMAS, and then add 2, whereas we want 2 add y to be divided by x. So we put brackets around all of it. Root x plus 6. So again, we only have the root symbol. So we type in x plus 6, but I don't need brackets because I want to root all of it. Root x plus 6. So root x, sorry, I calculator wouldn't put the x underneath the square root. So it'll be root x plus 6, with no brackets needed. 3 to the power x, so 3 to the power x. X to the power y plus 5, x to the power y add 5. If I did that, it would do this bit first, because BIDMAS indices come before adding. So x to the power y, then add 5, whereas we want x to the power y plus 5. 2 lots of y squared plus 5, so 2 lots of y squared plus 5. Root x over 5, so root x over 5, but we want x over 5 to be in the square root, whereas this one we don't, so just root x divided by 5. 2 times y to the 5, So 2 times y to the 5. This one, 2 times y to the power 5. I need brackets. Well, it's quite obvious in that one. 1 over 2 times y. But again, if I didn't have brackets, it would be doing 1 divided by 2 is half, then times by y. But I want to do 1 divided by 2y, so I need brackets. A half y, so 1 divided by 2 times y, that would be enough. If you want to put brackets around that. However, BidMaths would do this bit first anyway, so you get a half times y. 2 divided by y cubed, so 2 divided by y cubed. Again, that's fine without brackets because it would do indices first, so do y cubed, then it would do 2 divided by y cubed. But if you want to put brackets, they'll obviously be there. You don't need them. Then 2 divided by y all cubed. Okay, so since we had to do that in a calculator back in the day, that really helped us understand what was where and how algebra really worked. So I think, so next year I'm going to go back to that with year 12. I'm going to ban them using calculators and get them thinking using old-fashioned calculators. I might even try and dig out a few. Okay, whereas this one, you're going to work backwards and see if you can write it in normal written form. So the first one, we wouldn't write times, so it would just be x add 2y. X add 2 times y. Well, x add 2, we normally put the bit in the front, although you could write it as that, doesn't really matter. 5 divided by x add 2, so we do the dividing first, so it'd be 5 over x, then we would add 2. Whereas this one, 5 divided by x add 2, so it'd be 5 divided by, and x add 2 on the bottom, but we normally don't put brackets on fractions, even though they're there, we don't have to write them, because as long as our line is long enough, it's obvious that we mean all of that. 3 to the power x, take away 5. 3 to the power x, take away 5. Whereas 3 to the power x, take away 5, so this is first, so that's going to be my power. Root x plus 5, so root x plus 5. Whereas root x plus 5 is in brackets, but root, and we wouldn't need brackets. X plus 5. Root x plus 2 divided by 5. So root x plus 2 is under the bracket, under the square root, and it's divided by 5, so it's divided by 5. Whereas root x plus 2 divided by 5, so the first thing we do is root x, then we do the dividing, so 2 divided by 5, then we'd add root x plus 2 divided by 5, so square root goes over everything. Then we do the divide first, so 2 over 5, x plus, like that. And then last one, square root x, so square root goes over everything. Then it's divide, and x plus 2 is on the top, and 5 is on the bottom, so like that. Yeah, so hopefully you're starting to see as well that when you will write stuff, when you need brackets and you don't need brackets, and it's important that you get your square roots the right length, you get your fractions the right length, so you can see exactly what's on the fractions. Okay, and one last bit about brackets. So sometimes when you write answers, you forget to put brackets. So all I want you to do is in this table, just pick a number, sub a number in to both sides for x to show that both of these aren't equal. So if I picked 1 on this side, I would get 1 plus 2 pi, whereas on this side, I would get 3 pi, and they're not the same number. If I sub 1 into here, I would get 1 squared is 1, then minus 1. Whereas here, I get minus 1 squared is 1. Yeah, because BidMaths would do the power first, and then times by minus 1. Whereas here, we're forcing it to times by minus 1 first, then do the power. 3, let's do 1 wouldn't work here, so let's do 2. So we do the power first, so 2 squared is 4 times 3 is 12. Whereas here we have to do the times first. So 3 times 2 is 6. Squared is 36. That's right what I used for x. X is 1, x is 1, x is 2. This one, let's use x as 1 again. So 1 add 5 squared. So you do the squared first. So 25 add 1 is 26. Whereas here 1 add 5 is 6. Squared is 36. This one, I think x is 1 should work, yeah. So 1 add 1 is 2, squared is 4, and minus, so it's minus 4. 1 add 1 is 2, then I minus it first, so I get minus 2, then I square it, minus 2 squared is 4. Let's choose 1 again here. 4, take away 1 is 3, add 3 is 6. Remember with BIDMAS, times and divide, you do the order they're written, and add and taken away, you do the order they're written. So BIDMAS, it looks more like this. Yeah, you don't have to do the add before the take away. When you've got an add and a take away, it's doing the order it's written. So 4 take away 1 is 3, add 3 is 6. Whereas here we'd have to do this bit first. So 1 add 3 is 4, 4 take away 4 is 0. Yeah, so hopefully you can see why it's important, and especially when you have negatives. Look, 1, 2, 3 of these involve negatives. So just be very careful and think, do I need brackets in this answer? So why do you think the answers are different in the above examples? Well, it all comes down to BIDMAS, the order of operations. Why might the expression sin x add 10 be ambiguous? So ambiguous means have more than one meaning. And again, if I was doing something like x equals 1, some people might read that as do sine 1 first, then add 10. And some people might read that as sine, add 1 first, to do sine of 11. Now, in actual fact, the way it should be done is this first one here. It should do the operation first and then add 1. So if you wanted this, you would need to put brackets. So how does calculus fix this? Well, calculus fix this by, as soon as you type in sine on your fancy calculus these days, it opens a bracket for you straight away. So if you wanted the first case, you'd have to type in sine x, close bracket, then put plus 10. Yes, so there's always a bracket inside the sine, and I like that notation because that emphasizes that sine is a function. Yeah, you put numbers in a function, just like square root puts the bracket and the square in. Yeah, as soon as you do the power button, you get the square up there. So it's emphasized that those are functions. And how should you write it to avoid ambiguity? Well, the way I like to write it is I like to write anything that could be confusing at the end. So sine x at 10, I'll just write that as 10, add sine x. Or for some like sine x minus 10, I would write minus 10, add sine x, just to avoid any confusion. And what's the mathematical convention? Well, the mathematical convention is we try and put the numbers at the front, like we just said, or we can use brackets. So either 10 add sine x or sine x add 10. Yeah, so the convention would be that we either use brackets to show it's a function, or we put the numbers in the front. Okay, and the last bit is we're going to go back to inverse functions now. So now that we've practiced the algebra, we've practiced a bit of function work. So we're going to look at how we find inverses. And again, we've done this at GCSE. So the trick we're going to do is to find an inverse, we're going to call the inverse y. So y would equal f inverse of x. Then we apply f to both sides, look. So I get f of y equals f inverse x. And you know f and f inverse cancel. So we get f of y equals x. Then all we do then is sub in y into our function and rearrange to get y equals. So here's an example which is done for us already. So the function is 3 orths of x minus 2 squared plus 5. So if y equals, if we call the inverse y, just to save on our notation, then f of y equals x. So we get f of y, if I sub y into there, I get look at 3, y minus 2 squared add 5, and I make that equal x. So I rearrange it. So I take away 5 from both sides. I divide both sides by 3. I square root both sides. I add 3 to both sides. So I've got y equals this, but y will also equal the inverse. So therefore the inverse equals this thing here. Okay, so I know that one's written for you just so it's in your notes and you can go back to it. Whereas let's do one live here. So here's the function. So the trick is always we call the inverse y, and I'm only choosing y because it links with graphs. You can choose any letter you want really. So y equals f inverse x. So I do f for both sides. So I get f for y equals, well, that will just turn to x because f and f inverse cancel. So then I sub in y into f. So I get 4 add root y add 2 equals x. And then I rearrange to get y equals. So take away 4 from both sides. Square both sides. Okay, before I do anything to both sides, I'm just going to, actually, no, I'm going to leave it expand factorized and take away 2 from both sides. So there we go. For y equals, but y was my inverse. So my inverse equals x minus 4 squared minus 2. Yes, I've just left it in completed square form, so I can easily see the minimum if I wanted it. And that's it. That's what there is to it. Here's a few more, so you might want to try some of these yourself. It's the same thing. I'm going to miss out that step and just straight away just say y equals f inverse. So then do x equals y add 2 or 2y take away 3. Yeah. In fact, I'm going to write that down just so you can see where it comes from. Remember, f of y equals x, so x equals f of y. So I'm trying to get y equals, so I'm going to times both sides by 2y minus 3. So x lots of 2y minus 3 equals y add 2. I'm going to expand the bracket. 2xy minus 3x equals y add 2. Now I want to get y equals, so I need all the y's on one side. So I'm going to take away y from both sides. And I'm going to plus 3x to both sides. Now I've got y's on one side, I can factorize it out. And I can divide both sides by 2x minus 1. That's it. So my inverse, that's right, that's the last step. Is that? Okay, next one. It's the same thing. Y is the inverse. So f of y equals x. So x equals f of y. So y over y add 1 minus 2. So add 2 to both sides. X add 2 equals y over y add 1. Times both sides by y add 1. And look, I need brackets because I need to say all of this times y add 1. If I didn't have the brackets around that, it would just be 2 times that, then add x. Expand, so I get x times y, x times 1, 2 times y, 2 times 1. And I want all the y's on one side. So I'm going to take them to this side. So I'm going to take away the xy. I'm going to take away the 2y from both sides. So I'm left with on the side x and 2. Now I can factorize out the y here. 1 minus x minus 2. And in fact, actually, I could simplify that, couldn't I? So x add 2 is 1 minus 2 is minus 1. So minus 1 minus x. And then divide both sides by minus 1 minus x. So I get y equals x add 2 divided by minus 1 minus x. And then my inverse is just that. or what I can do is I could factorize out the -1, divided as this, minus x at 1 over 1 at x. Okay, so I times by the minus. Remember, I can write -1 as 1 over -1, just times the bottom by -1. And last page. And these were 2 exam questions. So I've got 2 functions here, f of x and g of x, just written both in different notations. So find the inverse of f. So remember, y equals the inverse. So f of y equals x. So I get 1 over y at 1 equals x. So times both sides by y at 1. Expand it out. And I want to get y by itself, so take away x from both sides. And then divide by x. So therefore the inverse, it's 1 minus x over x. Okay, then part B. Solve f g of x equals 1 over 8. Now I remember this exam question. I remember speaking to all my year 13s afterwards, and they said, oh well, I just subbed in g into f, made it equal 18, and then solved it. Instead, however, think they just got us to work out the inverse. Let's see if we can use that. So if I do the inverse to both sides of this equation, f inverse in particular, I know what f inverse is. On this side, f inverse and f cancel out, so I've just got g of x equals f inverse 1 over 8. But I know what f inverse is, so I can sub it into there. So g of x equals 1 minus 1 over 8 divided by 1 over 8, which gives me 7. So g of x equals 7. And then g of x was 2x squared minus 3, and that needs to equal 7. So I add 3 to both sides, divide both sides by 2, and then square root. So x equals plus or minus root 5. And that's it. So instead of subbing in g into there and then making it equal 1 over 8, just use the fact you've already done the inverse to do that bit first. And the last one, we have a function g of x equals 3 minus 4x, and we want to solve the equation g of x plus g of x squared equals 0. Okay, well, let's look at these things separately. So let's do g of x. So that means g goes back inside x, so it's 3 minus 4 times g of x. So it's 3 minus 4 lots of 3 minus 4x. Expand, so 3 minus 12 plus 16x. So I get 3 minus 12 is minus 9 plus 16x. That's the first bit. The second bit, g of x squared is 3 minus 4x squared. So expand it, I get 9 minus 24x plus 16x squared. So I've got that bit now. Add them together and make it equal 0. So minus 9 plus 16x plus, and I don't need brackets when I'm plussing because you can add in any order. Well, the minus 9 and the 9 cancel out. So I'm left with 16x squared. 16x take away 24 gives me minus 8x equals 0. I can divide both sides by 8 because it's an equation. So I get 2x squared minus x equals 0. And solve that however you like. The easiest way would be factorize out an x. So I get 2x minus 1. So I get x equals 0 from there. 2x minus 1 equals 0. 2x equals 1. So x equals a half. So my 2 answers. So this booklet is, like I said, it's got all the key stuff to make sure your algebra skills are really strong, ready for year 13.